Hello, my name is Gisselle. I'm going to be going over this question number 1 from homework. So here we are asked the average density of a mixture of alcohol and water. So it's going to be, we're looking for this. So basically what we're being asked for is density 3. If it helps you out, maybe it helps you out more to draw everything. And basically you have volumetric flow rate 1, density 1. Here you have density 2, volumetric flow rate 2, and density 3, flow rate 3, right? So before we go into solving, let's take a look at what we're given. So we know that we're given water at 0.123. So that's basically the volumetric flow rate, right? Make sure you put the units in there too. We know that we're given specific gravity of 0.8 of alcohol, and keep in mind that when we're referring to alcohol, that's going to be specific gravity 2. So maybe it helps you to look at this as area 1, area 2, and maybe area 3, right? Then we're also given that for alcohol, the volumetric flow rate is 0.280 meters cubed per second. Okay, so now that we've gotten this far, remember if we've been using the equation VA, that is basically, remember VA is equal to your flow rate, so this would be the same as this. Okay, so we're gonna have two equations. Our first equation is basically going to be density 1, flow rate 1, plus density 2, flow rate 2, equal to density 3, flow rate 3. Then we're going to take the continuity equation, and remember this is going to be for the steady flow in the fluids. So that's just going to be the summation of the volumetric flow rates, which is Q1 plus Q2, and that's going to equal to Q3, right? So remember that we're solving for density 3, this right here. So what we could do is just plug in this equation 2 into equation 1. So let's go ahead and do that. So now that we have that, let's move everything else to the right, and let's move density 3 on the left. All right, so taking a look at what we were given flow rate 1, specific gravity 2, and flow rate 2. So what we are not being given is density 2. Keep in mind that we are given density 1. Remember, that is water. So we can either take 999 kilogram meters cubed, or we can take 1,000. In this case, I'm going to take it to be 999 kilograms meters cubed. Don't forget your units. But what we aren't given is density 2. So in order to find density 2, remember we are given the specific gravity 2, which is 0.8. So basically, specific gravity, you can take that to be like the density of, let's say, an object, or the density of something over the density of water. In this case, we're trying to find density of the object, which is basically density 2, right? So density 2 is going to be equal to your specific gravity 2 times density of water, which is density 1, right? And this is an S. Keep in mind, sorry, that looks like a 3. So then basically, this is going to be 0.8 density 1, right? So let's go ahead and plug this in to here, and that would give us density 1. Keep in mind that density 1, we could factor it out because you have another density 1 here. So let's just go ahead and factor that out now or later, whichever one you think is easier. And that's going to leave us with the specific gravity that we said, specific gravity 2, as well as your flow rate 2. This is all over flow rate 1 plus flow rate 2, So go ahead and plug in all of your values. Now you have everything. So that's going to be 999. Flow rate 1 is right here. So that's going to be 0.123 plus specific gravity. Remember that was going to be this right here, the 0.8. And flow rate 2, it's going to be that right there, 0.280. You can worry about the units later, so just go ahead and write the numbers. 0.280. So let's go ahead and plug this into a calculator. end. Okay, so when you solve that out, you get that your density 3, which is the mixture of alcohol and water, that's going to be equal to 860, and your units are going to be in kilograms meters cubed because those are the units of density. All right, so that is your final answer. Thank you.